Hi there and welcome to this video for Senior Physics on motion. This video we're going to start exploring forces, and subsequent videos that we're going to be running through will look at the concept of forces, including Newton's laws and how we apply them to various scenarios. But in this video we're just going to do the basics and run through some ideas of what a force is, how does it work, and how do we calculate resultant force. Now, as we know, a force is basically a vector. Now, a vector means that it can have magnitude as well as a direction. And we can then put these various forces together to produce what's called a resultant. It's the result of two or more forces that are applied upon an object in specific directions. And as a result, we can say, well, what's the overall force that's occurring? So let's give a simple example in a one-dimensional state. In this case, we've got an object which is shown by the blue box. Now, in this case, we've got two forces which are applied upon it. Now, just like we've done with all our vectors, we've used an arrow to show the direction of the force, and then you can see that each of the arrows has a unit which gives it the magnitude of the force that is applied. So on this object, we've got a 15 Newton force plus a 25 Newton, all acting in the same direction. So how do we calculate the resultant force? Well, the resultant force is basically, very simply, the result of what the 15 Newton is doing as well as the 25 Newton is doing. Now, because they're going in the same direction, we can add them together. So it's 15 plus 25 gives me 45, so that it's as though, even though I've got two forces acting on that object, it's as though I've got a force of 40 Newtons acting upon the object. They're added because both vectors are going in the same direction. But let's take a different scenario. Here I've got exactly the same forces, but they're acting in different directions. So I've got 25 Newtons acting from the left, and I've got 15 Newtons acting from the right. So to find the resultant force, or the result of those two forces, the direction has to be taken into account. So basically 25 is going in one direction, but the 15 Newtons is opposing it. Now, when we're dealing with vectors, we show opposition to a direction as being negative. Hence, 25 minus 15 equals 10. So by doing this scenario where I've got 25 Newtons acting on the object from the left and 15 Newtons acting on it from the right, it's the same as having a resultant force of 10 Newtons acting from the left. Remember that I take the two vectors away because in this case they're going in opposite directions. So that's easy when we're dealing with a one-dimensional state. And if you get a question along these lines, always draw a diagram so that way you can understand what's going on. We've got to work on the idea that we're dealing with balanced and unbalanced forces. All of this that you studied in probably year 10. Noticing that if we've got balanced forces, then there's no net movement, there's no resultant. If they're unbalanced, then we are going to get movement, and force is going to cause that movement. So not only can we have forces acting in one dimensional, i.e. on the same plane, we can have them acting in two dimensions. And in this case, we try and work together so that we can produce a right-angled triangle, which then allows us to work on the idea of using Pythagoras and trigonometry. So look at these two vectors. I've got 10 Newtons acting to the right, and I've got 5 Newtons acting straight up. Now basically, if I apply these two forces onto an object, it's as though I'm producing a vector triangle. And you can see here that that vector triangle, 10 Newtons to the right and 5 Newtons up, is the same as applying a force, a resultant force in red, at an angle of a specific size. It produces a right-angled triangle, which now allows me to use Pythagoras. So I can calculate that resultant force. The resultant force will basically be the square root of 10 squared plus 5 squared. And that gives me 11.2 Newtons. However, we're not going in a specific direction, we have to go at an angle. So we've got to work out what the angle. Remember, a vector is magnitude, 11.2 Newtons, plus direction. So let's work out the direction. Well, in this case, I'd use trigonometry, which is basically tan to the negative 1 of the opposite divided by the adjacent. The opposite obviously being 5 and the adjacent being 10 Newtons. So I get 10 to the negative 1, 5 over 10, which gives me 27 degrees. So my resultant force vector, the red arrow, will be made up of 11.2 newtons at 27 degrees to the horizontal if I apply those two forces on an object. So I hope that makes sense. Now, so that deals with not only one direction, dimensions, but also two dimensions as well. Now, excuse me. Let's just recap again using force components. Now, force components work on the idea that for every force which is applied upon an object, we're going to have not only a horizontal force, but also a vertical force. So let's just go back to our triangle that we had previous. Now you can see that the resultant force is basically shown in red. Now if I applied that resultant force on an object, which is sort of what we would do if we were pushing a box or pushing a trolley or what have you, we'd be acting at an angle. Now to solve things using the angle is very, very difficult, but if we convert it into both horizontal and vertical, then life becomes a lot easier. And what we can then do is resolve all the vertical components and all of the horizontal components. And if we use our law of conservation of energy, the horizontal components and the vertical components should all match up to what we started with at the beginning. So how do we work out the components? Well, we noticed, as I said, there's a horizontal component which is going to be shown by X and a vertical component which is shown by Y. So they can be solved using trigonometry. And basically we get one overall vector which is going to be our resultant. So how do we solve them? Alright, well it's very, very simple. We're just going to follow the process that we've got here on this slide. To work out the horizontal component, it's going to be the resultant multiplied by cos theta. Now theta obviously is the angle on the left hand side. So I've got the adjacent and the hypotenuse. Adjacent hypotenuse is cosine, so I get resultant times cos theta will give me the x, the horizontal force component. For the vertical component, I've got the resultant times sine theta. So y will basically be opposite with the resultant force being the hypotenuse. So the opposite over hypotenuse, which is sine, so resultant times sine theta. So if I substitute in these values, if I've got a resultant which is 45 newtons at 30 degrees to the horizontal, this is how we would solve it. The horizontal is the resultant 45 times cos theta, where theta is 30 degrees, so I get 39 newtons is applied in the horizontal. For the vertical, the resultant force is 45 newtons, the angle is 30 degrees, so it's 45 times sine theta, 30, which gives me 23 newtons. So what does that mean? Well, the resultant force of 45 newtons at 30 degrees to the horizontal is made up of 39 newtons horizontally and 23 newtons vertically. So those are the two components which are applied. So obviously, if we then had another object coming in, we could then work with them together. Okay, so let's look at a quick example, and we'll get you to actually practice this. So in this example, we've got a shopping trolley which required 30 newtons of force to move it on the handle, which was at 40 degrees to the ground. Calculate the horizontal and vertical components of this vector. Okay, so what I would suggest you do now is, using the information I gave you earlier, pause the video and have a go at this question, and we'll come back and look at your answers. So pause the video now. Okay, welcome back. So let's see how we did. Now the first thing I would do in this situation is draw a vector triangle. Now I know I've got 30 newtons acting down and it's at 40 degrees to the horizontal. So you can see here I've got my 30 newtons of force acting down and it's at 40 degrees to the horizontal. So that will be made up of an x component and a y component. Once I've got my vector triangle like this, it makes life easier to solve my components. So I do exactly like I did on the previous slide, which is made up of my horizontal component, which is my resultant, which is 30 newtons, times cos theta, where theta is 40 degrees. So my horizontal component of this vector is 23 newtons horizontally. Then I do exactly the same for vertically, where the resultant is 30 newtons again. The angle is 40, so it's 30 times sine 40, which is 19 newtons. So that 30 newton force which is applied at 40 degrees to the ground is made up of 23 newtons horizontally and 19 newtons vertically. Okay, well I hope that's introduced forces for you and recapped on some of the ideas that we've had on vectors. I look forward to you joining me again, where we're going to study more work on forces. So thanks for watching.